Hi everybody, today you are going to talk about Azure Synapse Analytics, that is formerly known as a SQL data warehouse, is a cloud-based integration analytics services that provide that is also provided by Microsoft Azure. It's designed to analyze a large volume of data and support both on-demand and provisioned resource for processing analytical workload, and that offer the end-to-end analytics architecture with Azure Synapse that is involve several component and stage. So let's discover this together. So the first compound is the data integration. Essentially is represented by the Azure Data Factory. That is a cloud-based data integration services that allow you to create data-driven workflow to orchestrate and automate the data movement and the data transformation. You can use the data factory to ingest data from a various source into your Synapse Analytics environment. The second compound is the data storage. That is essentially represented by the Azure Data Lake storage that is known by the name of ADLS. That Azure Synapse Analytics integrate seamlessly with the Azure Data Lake storage. That is a scalable and secureable data lake. The ADLS always you store structured, unstructured, and data in it is native format and provided the flexibility to scale storage resource based on your needs. The second compound, or the third compound, is the data warehousing. The Azure Synapse Analytics, that is formerly a SQL data warehouse, this is a core compound of storing and processing a large volume and of structured and unstructured data that is offer a provisioned and on-demand resource to support a different type of workload. So Synapse Analytics use a massively parallel processing that is known with MPP architecture that allow you to scale a resource horizontally to handle a large dataset. So the next compound is the data orchestration is included by the Azure Synapse Studio. The Azure Synapse Studio is an unified workspace for a big data and a data warehouse management. It provides a collaborative environment for a data engineer, a data science, and a business analytics to work together. A Synapse Studio allows you to develop, monitor, and manage workflow for the data transformation and data analytics. The next compound that we found in the Azure Synapse Analytics is the data processing. So the data processing is represented by Apache Spark. Azure Synapse Analytics support the Apache Spark for a big data processing. By Spark, we can provide a fast and a general purpose cluster that use a framework for large scale data processing. With Synapse, you can use Spark to perform analytics, machine learning, and graph processing on large datasets. The next compound is the data querying. That is written by the T-SQL, the Transact SQL. By the Azure Synapse Analytics, use a SQL-based language for querying and analyzing data. You can use the T-SQL to interact with both structured and semi-structured data and store in your data warehouse. The next compound is the Power BI integration. The Power BI integration is a business analytics services that provides interactive visualization and a business intelligence capability. You can connect Power BI to your Synapse Analytics instance to create report, dashboard for data and analysis visualization. So the next compound is the security. The Synapse Analytics provide a robust security feature that include a data encryption, role-based access control right now by airbag and auditing. It also compile with the various industry standard and regulation to ensure that data security and compliance. So to resume, by integrating those compounds, Azure Synapse Analytics offer a comprehensive end-to-end analytics solution that cover a data ingestion, storage, processing, querying, and visualization. So this architecture that can provide the flexibility to scale resource based on the evolving needs of your analytics workload. The solution that is shared on the screen combine a range of Azure services that will ingest, store, process, enrich, and serve data and insight from a different source that is a structured, semi-structured, unstructured, and a streaming resource. So for the data flow that is shared here in the screen, the analytics use the architecture are illustrated by the different data sources. On the left-hand side, the diagram and the data flow through the solution from the bottom up as following. So the Azure Data Services cloud native HTTP with the Azure Cosmos and the Dataverse provide us to process the data using Azure Synapse Link for Azure Cosmos DB and Azure Synapse for Dataverse that enable us to run a near real-time analytics over operational and a business application by using the analytics engine that are available from your Synapse workspace as known as SQL, Serverless, and Spark Pool. Second, when using Azure Synapse Link for Azure Cosmos DB, use either a SQL serverless query or a Spark Pool notebook. You can access to the Azure Cosmos DB analytical store and then combine the dataset from your near real-time operation that get your data lake from the data lake into your data warehouse. Third, when Azure Synapse Link for Dataverse, use either a SQL server serverless query or a Spark Pool notebook. You can access to the selected Dataverse table and then combine a dataset from your near real-time business application. That data is ingested from your source into your data warehouse. And then let's talk about the store of the data. The resulting dataset from your SQL serverless query can be persisted in your data lake if you are using a Spark notebook. The result dataset can be persisted either in your data lake or your warehouse as non-SQL pool. And then to serve, there is three steps that we can describe. For the first one is to load relevant data from the either Synapse SQL pool or a data lake into a Power BI dataset for data visualization and exploration. A Power BI model implements a semantical model to simplify the analysis of your business data and relationship. So in this case, the business analysts use Power BI, report, and dashboard to analyze data and retrieve business insight. The second step is data can be securely shared to either other business unit or an external trusted partner using either data share. The data consume have the freedom to choose what data format that want to use and also what compute engine is the best for the process and the share dataset. The third step is to uh, to represent the data that is um, a relational or an unstructured data that is stored into your Synapse workspace can also be used to build knowledge meaning solution and use AI to uncover available business insight across a different document type and format, including the Office document, PDF, image, audio, forms, and web page. So now let's talk about the relational database. For the ingest part, we can use a Synapse pipeline to pull data from a wide variety of datasets, both on-premise and in the cloud. Pipeline can be triggered based on a predefined scheduler in the response to an event, or can be explicitly called via REST API. And then to store data within the raw data lake layer, organize your data lake following the best practice around which layer to create, what folder structure to use in each layer, and what file format to use for each analytic scenario. The second step is from the Azure Synapse pipeline, use a copy data activity to store the data copied from the relational database into the raw layer. Of course, this raw layer is included into your Azure Data Lake Storage Gen 2 data lake. You can save the data in a delimited text format or compress it as a Parquet file. And then to process those data, we can use a data flow, a SQL serverless query, or a Spark notebook, ever to validate and transform, also to move data set from a raw layer through the enrich layer into your created layer in your data lake. As a part of your data transformation, you can invoke machine learning model from your SQL pool using a standard T-SQL or a Spark notebook. This ML model can be used to enrich your dataset and generate further the business insight. This machine learning model can be consumed from Azure Cognitive Services or a custom ML model from Azure ML. And then to serve your data, you can serve it finally the dataset directly from the data lake, query that layer, or you can use a copy data activity to ingest the final dataset into your SQL pool table using the copy command for fast integration. To load the relevant data from Azure Synapse SQL pool or a data lake into Power BI dataset for data visualization. So Power BI model implement a semantical model to simplify the analysis of a business data and our relationship business analytics use Power BI to report dashboard and analyze and derivative business insight. The third part is data can be also secured, shared to the either business unit, external trust partner, use also the same thing is the Azure data share. Data consumer have the freedom to choose what data format that want to share and want to use for the compute engine and what is the best process to share datasets. Fourth, the structured and unstructured data stored in your Synapse workload can be also used to build a knowledge mining solution and AI uncover valuable business insight across your different document for all type. So next let's have an idea about the structured, semi-structured data source. So the first thing, the same for relational and unstructured data, the same thing is the ingest part that we can use as Azure Synapse pipeline to pull data from wide variety of semi-structured data source, both on-premise and the cloud. For example, to have an ingest data from file-based source containing CSV or JSON file, or also you can connect to NoSQL database such as Azure Cosmos DB or MongoDB. Also, you can call the REST API provided by SaaS application that will be function as your data source for the pipeline. So next, to store those data, those semi-structured data, you can use the row of the data lake layer. Organize your data lake following the best practice around which layer to create what folder structure to use in each layer and what file format to use for each analytics scenario. So the next thing to store semi-structured data is using Azure Synapse pipeline to copy data, use to the activity of copy data to stage the data copied from the structured data source into the raw layer of your Azure Data Lake storage Gen 2 and save data to preserve the original format as acquired from the data source. Then to process data for batch, micro-batch, pipeline, use either the data flow, SQL, serverless query, or Spark, a notebook to validate, transform, and move your dataset into your created layer in your data lake. So use SQL serverless query to expose underlying CSV, Parquet, or JSON file as external tables so that they can be required using T-SQL. So as a part of your transformation, you can invoke a machine learning model from your SQL pool using a standard T-SQL or a Spark notebook. This ML model can be used to enrich your dataset and generate a business insight. This machine learning purpose, and also we can uh, build a model can be consumed from the cognitive services and use also a custom ML model from Azure ML. For the second thing in the process part, that of near of real-time telemetry and time series analytics scenario, we can use a data explorer pool to easier ingest and consolidate and correlate your logs and IoT event data across our multiple data sources. With the Data Explorer pool, you can use custom query to perform a time series and do spatial clustering. So to serve data, we can use four things. So we can use serve data directly from the data lake, created layer, or you can use a copy activity to ingest data to the final dataset into your SQL pool table using the copy command. The second thing is to load relevant data from the Azure Synapse SQL pool, a Data Explorer pool, or a data lake into a Power BI dataset for the visualization part. So the Power BI model can implement a semantic model to simplify the analysis of business data and relationship. So for the business analytics, they can use Power BI to report and dashboard to have a more insight from the business part. So the structured and unstructured data stored in your Synapse workspace can be also used to build a knowledge mining solution and use AI to uncover the valuable business insight across the different document format. So now let's talking about the streaming data. For the ingest part, we can use the Event Hub or Azure IoT Hub to ingest data stream generated by the client application or IoT device. The Event Hub or IoT Hub will then ingest data and store it, streaming data providing for the sequence of event received, and the consumer can be connected to the Event Hub or IoT Hub endpoint to retrieve data for processing. And then how about the store of the data? Within the raw data lake layer, organize our data lake following the best practice around which layer to create what folder structured, and to use each layer, and what file format to use each analytics scenario. So the second thing is to configure the event hub capture or the IoT hub storage endpoint to save a copy of the event into the raw layer of your Azure Data Lake storage and to that is always into the data lake. This feature that can be implemented in the cold path or the Lambda architecture pattern, and always you to perform the historical and the trend analysis on the stream data saved into your data lake using the SQL serverless query or a Spark notebook. So how about the process? For the real time, inside we can use a stream analytics job to implement the hot path of the data lambda architecture pattern and derive insight from the stream data in transit to define at least one input of for the data streaming coming from your event hub or IoT hub. One query to process into one input data stream and one for Power BI output, whatever a query result that will be sent to. So as a part of this data processing within a stream analytics, you can invoke a machine learning model to enrich your stream dataset and derive um, a business decision based on the prediction generated. So by using in this way the machine learning model and can be consumed from the Azure Cognitive Services for also a custom ML model used in the machine learning. The second thing is we can use a stream analytics output to send a processed event to Azure Synapse SQL pool and a Data Explorer pool for those analytics use case. And finally, the third one that we can use for this process part is have a near time telemetry and a time series analytics scenario. Use a Data Explorer pool to easier ingest the IoT event directly from the Event Hub or IoT Hub. With the Data Explorer pool, you can use a custom QL to perform time series analytics or also the same thing, the geospatial cluster. And then finally, the last thing is how to serve those data that is processed and exposed. So the first thing that we can um, present here is to use a business analyst Power BI into a real-time data set and a dashboard that is now possible using Power BI for fast changing insight and generate your stream analytics query. The second thing is can be secured to the business unit by using Azure data share that we can use it freedom to choose what is the format and what is the part of data that we want to share with the other user. And also use the unstructured and structured data Synapse workspace to have to store our streaming data that can be valued by the business insight.